So planning of experiment 2021 session papers. The first one, a student investigates the motion of a ball rolling down a slope. Like there is a ball which is rolling down onto the slope. We have to plan an experiment which enable us to investigate how one factor affects the average speed. And you can select any one factor, like you can select a mass of a ball, you can select an incline, the angle of inclination, you can select the length of the ramp. So any one of the factor you can select because it did not specify. So how the average speed is affected by any one of the factor. The average speed can be calculated by a formula. Average speed is equals to total distance or distance traveled divided by total time. Whenever this question is there, planning of experiment, you will always try to write the answer according to the points. So the apparatus available, we have balls of various size and material. We have a board which can act as a slope, and we can have a block to support one, like we can have this block here, which can support this board so that we can make an inclination is there or angle can be changed, or we can make an inclined surface. In your plan, you should state factors, state factor which can be measured. So what factor can be measured here? So it's up to you, like example, or which factor you are finding is affecting. You can compare the mass of the ball, you can compare the size of the ball, or you can compare the angle of inclination. So factor which we are investigating for this. Example, I mentioned we are investigating the size of the sphere or the material which sphere is made up of, or we can say the mass. Then list additional apparatus that is needed. What additional apparatus we need? Because we want to find like how the mass is affecting the average speed. So what is the average speed? Average speed is the total distance over total time. How we'll measure a distance travel? So we need a meter rule or a meter scale to measure like what is the distance traveled by this sphere when it is moving on the inclined surface. So to measure this distance, what we need a meter rule or a meter scale. And to get the speed, because speed is distance over time, so we have to measure a time. So we'll measure a time interval from first marker to the second. So for that, what we need a stopwatch or a stop clock. So the second part, list any additional apparatus needed. What else we need? We need a meter rule or a meter scale and the stopwatch. The meter rule and stopwatch is needed for measuring the distance in time, and using a distance in time, we will get the average speed. Then explain briefly, like this is a procedure, explain briefly how you will carry out the experiment, include which measurements are taken. So what will be the experimental procedure, how we carry out this experiment? So using a meter rule, or we can just mark the position on the ramp and measure the distance between the 2 points, and we should avoid a parallax error. Then we'll start the timer when the ball reaches mark 1, and we'll stop the timer when the ball reaches mark 2. And the time interval is actually a difference between the two time at mark 1 and 2. So we will measure the distance or place two markers. on the ramp. Then we'll measure the time for ball to move from one marker to another. What is a ramp here? Ramp means whenever you have any inclined surface is there, like when you have a slope, this is called a ramp. This inclined surface, we can also say a ramp. So we will place two markers on the ramp, like on the inclined surface, and we measure the time for a ball to move from one marker to another, and we'll measure the distance between the markers. And we will use a formula that speed is equals to distance over time. So that will give us the speed at which the ball is rolling. So answer for the first part, there is a space available, but I'm using the question as a reference. So I'm writing all the answers here. Now state key variables to kept constant. Look, whenever you're doing it, and this is a variable, so it's a plural, like you have to write at least two or more than two. So what are the key variables we should keep constant for a fair comparison? We are investigating how the mass of a ball can affect the average speed. So what else should be constant? The key variable, so the incline, the angle, because the angle can also affect the average speed. So this angle which we are using for the ramp, that should be same. The material from which this ball, like because different type of materials will have a different friction. We are only changing the mass of a ball, but the type of a material, the material which we are using, that should also be same. And for every experiment, when we are repeating the experiment, because we place two markers on the ramp, we measure the time for a ball to move from one marker to another. Then we measure a distance between the markers. And then we'll repeat the experiment because we are investigating how the mass of a ball can affect the average speed. So we'll repeat the experiment with different mass of ball. So here the key variable which we should control or we should keep constant for a fair comparison, the angle of the inclined surface. And the second thing, the material which the ball is made up of, because different material will have different frictions. We are just changing the mass and identifying how the mass can affect the average speed for a ball as it rolls down. Then draw a table or tables with a column heading to show how you display the reading. So draw table or tables. So what table we can draw? And you don't have to write a number because you're not doing experiment. You're just mentioning how it can be done, but you're not doing the experiment. So you don't have to mention the numbers. So what we can have because the distance we kept same here, the distance between the markers same. So we are investigating how the mass is affecting. So example, mass and slash gram. SI unit of the mass is kilogram, but in the lab, we are not using 1 kilogram or 2 kilogram or 5 kilogram objects. Normally is in gram. That's why mass in gram. And then time in seconds. Why I did not mention distance? Because we are changing the sphere. Like first example, we use say 10 gram of a sphere. Then we use a 20 gram sphere. Then we use 30 gram sphere. So we are only changing the mass of a sphere. The distance kept same and recording a time to move from one marker to another. So this is a table which we will draw to represent how we present our data. Then explain how to use reading to reach a conclusion. How we'll know which one is having a higher average speed or which one is having a lower average speed. So there are two ways to do this. We can sketch a graph between a distance and time. Distance on y-axis, so we can sketch for this one. Yes, you can also say height. You can mention, because if you read the first part, they mention state a factor which can be measured, like plan in an experiment which enabled him to investigate how factor affects the average speed. So we can change the height from which the ball is rolled down. We can change the angle, the slope also. So there are many factors which can affect the average speed. I just started with the mass, which is a very simple. You can change to height as well. So what we will do, how you use your reading to reach a conclusion. So we'll sketch a graph. So this point, sketch or plot a graph, and you have to mention what you will plot on y-axis. So on y-axis, plot distance, and on x-axis, plot time, because we know distance divided by time, the slope represent the speed. So distance on y-axis and time on x-axis. So explain how you use your reading to reach conclusion. So we'll sketch a graph between distance and time, and the slope represent the speed. And the one which will have a steeper or a higher slope will have a higher average speed. But always these type of questions, whenever you answer planning of experiment, the last question in paper 6, try to answer according to the points which they ask, instead of writing the whole experiment. Because when you're writing whole experiment as a paragraph, that likely you miss any point. So it's better whenever you are answering a question related to the planning of experiment, try to answer according to the points which they ask. Then from May, June 2021, paper 6, variant 1, another experiment. A student investigate the rate of a cooling. Like student is investigating how the rate of a cooling or how much time the substance will take to cool down. Rate of cooling in air of heated block made of different material. The temperature of each block is increased by placing in a hot water. So it's what student did, like placing a different metals are there, placing them in a hot water, then taking it out and finding how much time it will take to cool down. Plan an experiment to investigate how the rate of a cooling depends on the metal from which the block is made. So we want to investigate how the rate of the cooling is affected by the material or the metal which the block is made of. The following apparatus is available to the student. A cylindrical block is there. You can see a cylindrical block. This is a cylindrical, and there's a hole for a thermometer. So thermometer, so that we can place a thermometer and record the temperature of a block. And using, like example, in 5 minutes or 3 minutes, how much there is a change in temperature for every 30-second interval. The one which shows a greater change in temperature, it means that metal cooled down faster. Or we can also plot a graph between the temperature on y-axis and time on x-axis. The one which is having a steeper slope, that means that cool down faster. So other apparatus normally available in a school lab are also used. In your plan, you should list any additional apparatus, because whenever you are measuring something, a rate is always with reference to time. Because like if I say rate of cooling, rate of heating, rate of energy change, rate of energy transfer, or rate of the reaction, so we always rate. Whenever the term rate is there, it means time should always be a factor. So list an additional apparatus. They already mentioned we have thermometers. So what else we need? We need a stopwatch or stop clock or a timer. Explain briefly how would you carry out investigation, include the measurement you would take. So how we will carry out this experiment? Because first a student places this metal block, a cylindrical metal block inside the hot water. Then we will take it out from the hot water. We'll record the initial temperature and we record the temperature for example 5 minutes or 3 minutes for a 30-second interval. And then we'll repeat the experiment with different metal cylinders. So how you carry out the experiment means the procedure. So we will remove the metal. So we'll remove the metal cylinder from hot water. That is one thing. Then we'll record the initial temperature. Because space I'm writing in short, but you will write full. So record the initial temperature. Then we'll start the timer or a stopwatch and record the temperature for any specific time interval you can mention, like 3 minutes or 5 minutes for 30 seconds interval. Like after every 30 seconds, we will also measure the temperature and we'll continue this till 3 minutes or 180 seconds. Then we'll repeat the experiment or repeat the procedure with different metals. So this is what we will do. That's the second part, that for carrying out the experiment, what is the experimental procedure? So remove the metal cylinder and then we'll record the initial temperature. We'll start the timer. We'll record the temperature after every 30 seconds and continue this for 3 minutes, or even you can mention 5 minutes, and repeat the procedure with the different metals. So this is done. Then state the key variable to be kept constant. Variable, again, plural. So you have to mention 2 or more than 2, not 1. So what you should keep constant for a fair comparison? If we are investigating the rate of the cooling, so rate of cooling depends on the starting temperature. So all the metals should have the same initial temperature. So one of the key variable that all the metals should have a same initial temperature should be same, or the starting temperature. When we are investigating, the initial temperature should be same. Second thing, the rate of cooling also depends on temperature of the surrounding. So temperature of the lab temperature, or we can also say the room temperature, should be same for all the experiment, throughout the experiment. Then the size of the cylinder, the metal cylinder, or the mass of a cylinder which we are using. The size of the cylinder should also be same, because if the size is different, then they will have a different rate of cooling. The rate of cooling can be affected by size as well. At least you should write 2, but you can write more than 2. So initial temperature, lab temperature, and size of the cylinder which we are using for different experiment, that should also be same. Then draw a suitable table with a column heading. With a column heading, so what table will make for with a column heading? So one side will be a time and the other one will be a temperature. And because we will have different materials, so we can make 2 tables, because as we are investigating 2 or 3 you can make. One is for material A, another one is for material B. So we'll have two columns. So as I mentioned, record the temperature for 3 minutes. So time is there and temperature. And same thing, time is there and temperature. We don't have to write any number, but here time is obvious. Like example, first what will happen, we measure when at the beginning of experiment, we measure the temperature. Then after 30 seconds, we'll measure a temperature. Then after 60 seconds, we'll measure another temperature. After 90 seconds, after 120 seconds, after 150 seconds, and till 180 seconds. Because 180 second means 3 minutes. So we continue till from start. So after every 30-second interval, we are measuring a temperature to identify how the rate of cooling is affected by the type of a material. The surrounding or the type of material. So draw a suitable table or tables. So we did that. Then explain how would you use the result to reach a conclusion. So whenever you want to reach a conclusion, there should be some data in front of you, or you should have a graph. So what we will do, we will plot a graph between the temperature. So we'll plot a graph between the temperature on y-axis and time on x-axis. And as you can see, it is obvious if it is a rate of cooling, the temperature will decrease with the passage of a time. So how we identify which one cool down faster or which one take longer time to cool down or which is having a faster rate of cooling. So for a temperature and time graph, the slope represent the rate of cooling. The one which is steeper slope will have a higher rate of a cooling. So as you can see, B is having a steeper slope, or A is having a steeper slope than B. So it means A will have a faster rate of cooling, or A temperature changes much faster or quicker compared to B. So what about how to write the last part, answer for the last part? So we will plot a graph between, and you have to mention which axis you will take temperature and time. So plot a graph between temperature on y-axis and time on x-axis, and the slope or the gradient shows rate of cooling. So the experiment which is having a steeper slope, because space I will utilize this part. So the experiment which shows steeper slope or a greater slope is having faster rate of cooling. And there is another question from the same 2021 session. You will find a pattern, you will find a similarity between the experiments. Common experiment is about rate of cooling, or sometimes it's about time period of a pendulum, and rarely you will find a question related to or experiment related to lenses. It is there, but not too many questions. Most common one is about rate of cooling. So this is from October, November 2021, paper 6, variant 1. A student investigate the time to heat water in different insulation or insulated container. So a student is investigating like how much time it will take to heat up the water in different types of containers. The containers all have the same volume and the shape. The water is heated with an electrical immersion heater. So a student is having an immersion heater, and immersion heater means like we can put inside the object or a material and it can supply the heat energy. The following apparatus is available. A selection of a container, like we have a variety of containers, measuring cylinder, thermometer is there, and supply of a cold water and immersion heater with a power supply. Plan an experiment to investigate the time taken to heat water in different insulated container. So what we will do, simply how we plan this experiment, like we'll have different containers, but they mention they have the same size. So size of the container or shape of the container is same, but we'll have different containers. By using a measuring cylinder, we'll take equal volume of water inside. So equal amount of water we should take inside these containers. And then we'll place immersion heater. The heater is placed here inside container A, container B, and container C. And then, because we want to investigate how, like the time to heat a water in different how the time is affected. So example, we want to carry out a 10-degree change. So all the experiment, when we start, they should all start with the water at a temperature of 20 degrees. Initial temperature should be same. Yeah, we should use the same type of a heater as well. Like the heater is used. And then what we are doing, we should place a thermometer, because we are investigating how the time is affected or time taken to heat the water in different insulating materials. So we have thermometer in the second one, and the thermometer is placed in the third one. So what we will do, we will switch on the heater and we will start the timer as well, or using a stopwatch, we'll start the time. And once the thermometer reading reach 30 degrees, like once the thermometer reading reach 30 degrees, we'll stop the timer. So the one which take a shortest time, it means that is a good insulating material. Say thermometer, when we are doing the experiment with A, it took 10 seconds to reach 30 degrees. When we did for B, it took 30 seconds to reach 30 degrees, from 20 to 30. And for C, from 10 to 30, maybe it took, say, 12 seconds. So which one is a good insulator, or which is not allowing the heat to escape? The one which is taking a short time to heat up, it means that is a better insulator. So what additional apparatus we need? As they did not mention anything about thermometer is there, but the timer is not mentioned. So what we need a timer, or we need a stopwatch. Explain how would you carry out the experiment. So how we'll carry out the experiment? We'll take equal volume of the water in different containers, or you can mention one and then repeat with others. You can also mention like this. So we'll take, like example, 10 cm cube of water in first container, records its initial temperature, and then we will switch on the heater and start the timer until it reaches, or it shows a 10-degree change in temperature. Then we'll repeat the experiment with the different types of containers. So place 10 cm cube of water in first container, record the temperature, switch on the heater, and the timer, the stopwatch, then record the time for heater, to change temperature by 10 degrees. And then we will repeat the experiment. Containers. So this will be the procedure, how we carry out the experiment. This is the whole procedure. Then state the key variable which we should keep constant. So what are the key variables we should keep constant for a fair comparison? Amount of the liquid which we use, or volume of the liquid, or volume of water. The rate of heating or cooling depends on the surrounding temperature as well. So temperature of the lab or room temperature you can mention. It also depends on the amount that we already mentioned, type of the heater which we are using. And initial temperature. The starting temperature should be same for all of them. Then draw table or tables with a column heading. So we can have, like example, for container A and for container B. So the temperature and time. Here also temperature and time. Like if we start with a 20, then 30. So here the time is 0. It can be any other number. Same thing for the second container. We started with time 0. How much time it will take to reach 30 degrees. So this is container A and container B. It can be C. You can make more, because as I mentioned, draw table or tables. You can merge them, or you can make a separate table for each observation. Then how would you use your reading to reach a conclusion? So how we'll use our reading to reach the conclusion? So same thing, we can plot a graph between the temperature on y-axis and time on x-axis. Here we are increasing a temperature. So temperature will increase with the passage of a time as we are supplying the heat energy. How we'll know which one is a better insulator? So the one which take the shortest time, or which is having a steeper slope. So experiment which take shortest time to change 10 degrees centigrade shows that it is a better insulator.